So this will actually be the highest resolution mapping that's been done in Iron Bottom Sound.
Hey Nautilus Live! For the NA-173 expedition here in Iron Bottom Sound, a big part of our coordinated technology approach is that we are bringing together the remotely operated vehicles and the uncrewed surface vessel DriX. And DriX is operated here from Honiara, Solomon Islands, in this control room right behind us. So we're multiplying the efforts of vehicles put together to be able to get better maps than we've ever had of the seafloor here, and then to go and visit the sites. Let's go check it out.
How's it going? My name's Avery Munoz. I'm a research engineer with the University of New Hampshire. I'm here at the ROC, the Remote Operations Center for DriX 08, and we're getting ready to get underway today, do some operational testing, and make sure that we're ready to support NA-173 with DriX 8. We are a team from the University of New Hampshire that are out here operating DriX number 8, which is an autonomous surface vehicle. DriX is out here to work with the Nautilus and some of the other assets that are on site to support some of the mapping efforts on NA-173. There's a lot of wrecks out here. There's some stuff that's unidentified. There's some stuff that has been identified. And we're hoping to be able to provide really accurate positions of where these wrecks are. So the DriX is essentially just a standard survey platform, but it's adapted so that everything can be operated remotely. So we have an ROC set up here in the Solomon Islands on shore, just near our operational area. But we also have an ROC set up on basically the other side of the planet. It's really exciting because it gives us increased mapping capabilities. It's difficult sometimes to drive a boat when you're on the boat. It's especially difficult to drive a boat when you're potentially hundreds of miles away. So this interface gives us feedback to all of the data, all the systems on the boat. It is essentially our eyes and ears when we're operating. We get full control of every system on the DriX through this interface. So we can control the OAS system for obstacle avoidance. We can control basically just the direction of the DriX. We can tell it to go to a certain spot. We can see the radar feedback in here. So we see obstacles on the surface. We see the feedback from the LiDAR as well. We always keep our RGB cameras up at all times so that we have good situational awareness of everything around the DriX at all times. We've got also a lot of the telemetry feedback from the engine on board, from the electrical systems on board. If you think about like a large boat getting underway, they have engineers on board that can go down to the engine room and fix things. And when there's nobody on board, you can't do that. So we have feedback from all of our systems. We have sensors all over the boat, and all of that data gets aggregated in here, and we can see whatever's going on board so that we have a good understanding of what's happening around the boat, in the boat, at all times.
We came to Iron Bottom Sound looking to get very, very high resolution video and imagery of some of the well-known wrecks of World War II. Some of those we had verified locations for. We knew where they were, but for many, we really have no idea where they are. And one of the things we've been doing over the last few years with the support of NOAA's Office of Ocean Exploration through the Ocean Exploration Cooperative Institute is trying to develop approaches for really optimizing ocean exploration. And I think what we have here is a perfect example of how we can do that. By using our uncrewed surface system, the DriX, we can really optimize the exploration where Nautilus will go with the ROV to a known wreck and we start surveying. And while that's happening, totally independent of Nautilus, we have the DriX out surveying with a sonar that has the capability we've demonstrated of finding some of the larger wrecks. All right, so here we have the bathymetric data, the depth data that the DriX has collected. What you'll see as I zoom in is even in these water depths, and we're sitting in this area now, we can very, very clearly see from just the depth alone the indication of a wreck. This happens to be the Canberra. That was one of the ones we had a verified position for. And what we did was we would start with these to see what the DriX could find. But as I said, we tried to look for even better ways to have these targets jump out at us. And one of the things we found is if we look at the slope of the surface, and if I look at it in 3D, we can see that very, very, very much has the shape of what we'd expect from a wreck. So this has been a very, very helpful tool for us to pinpoint potential targets. But most importantly, looking for something that's really out of context with the surroundings. And this was one of our really exciting finds of an unknown wreck. We see a very, very some subtle targets up here. If I look at the bathymetry, again, I'm seeing something very, very subtle here, but it just looked a little strange. And so we picked that one as a target that should be investigated by the Hercules, and that turned out to be the bow of the New Orleans. We've had, I think, 4 now wrecks. The DriX is found that didn't have locations, and it was so exciting to me to watch our experts rewriting history. We have probably found 40 or 50, but each one needs to be investigated more carefully. I think from those 40 or 50, we'll probably get it down to a few dozen that we really think are worth pursuing and investigating more. We go through this process of looking at the slope, looking at what we call the point cloud. We look at shoal surfaces, all these indicators, and most importantly, that idea of the context, the geologic context. We had at least 2 occasions where we dove on targets that we thought might be real. They had the right dimensions, but they were geologic features, and that's going to happen. So I think we've got a few dozen in our pocket, I think, that are probably well worth coming back to.